Hello, welcome to all. On behalf of Hindustan College Science and Technology, Mechanical Engineering Department, here we will discuss some topics under that subject titled as Renewable Energy Sources, Thermoelectrical and Thermionic Conversions, its working principle, performance limitations, and the second part, wind energy, wind power sources, momentum theory, classification, routers, etc. etc. So first of all, we'll discuss thermoelectrical energy conversion. So principle of thermoelectrical energy generation is depend on the thermoelectrical energy devices. And these devices are termed as solid state devices, which is used for thermal conversion of thermal energy into electrical energy and work on the Seebeck effect. So in 1821, Seebeck has invented a different kind of concept in which two dissimilar metals are joined at two different junctions, and when these junctions are maintained at different temperature, an EMF is induced at these junctions, and due to this induced EMF, a current start to flow an external load, and this effect is known as Seebeck effect. Amount of generated voltage, or we can say EMF, it is equal to V equal to alpha times delta T, where alpha is the Seebeck coefficient and delta T is the temperature difference is maintained at junction. In detail, we will have a look on this diagram so that I can explain nicely to you. We can see here two different kind of metals, say metal A and metal B are joined at a junction, and another one junction is here, and with the help of some external heat source, this junction, the temperature of the junction is increasing, and by keeping constant of this temperature, this junction of this temperature of this junction, so that this junction is termed as cold junction and this junction is termed as hot junction. Because of this temperature difference, as per the Seebeck effect, an EMF induced in between this hot junction and cold junction, and because of this induced EMF, a current start to flow in external load. So this is known as Seebeck effect. Another effect is the Peltier effect, which is termed as a reverse effect of Seebeck effect. In place of maintaining two different temperature, that we can say temperature difference, if we maintain a potential difference, so become EMF, then some part of the closed loop is got heated hot, and other part of this closed loop becomes cold, and this is, we can say, reverse effect of Seebeck effect, which is used for thermoelectric refrigerators and calculation of efficiency of thermoelectric generators. So another one device this device is known as thermionic conversion, or we can say Thomson effect. So Thomson effect is what? When a current carrying conductor, say for a long wire, which is capable to carrying conductor, is maintained potential current carrying conductor is maintained temperature difference at its ends at two different terminals, then it is start to absorb heat from surrounding or emit heat to surrounding. So this effect is known as Thomson effect, and which is basically or mainly depend on materials property. What kind of material is going to employ for this? So what type of properties the material should possess so that it can reflect and can execute this type of effect, Thomson effect. So these properties are listed over here. So for number one, that metal should have high Seebeck coefficient, low thermal conductivity in order to reduce heat losses, and should be stable to high temperature region. So sustainability under high temperature, for this stable in high temperature region. Fourth one, low electrical resistivity in order to reduce losses during the flow of current throughout the conductors. So losses should be there in order to minimize the losses. So low electrical resistivity should be there. At last, when metals is heated and then it reacts with surrounding oxygen and metal oxide form, and metal oxide is nothing else is a corrosion. So in order to prevent corrosion, so materials should have high corrosive resistance. So what kind of materials you would like to prefer for this, for getting this kind of effect, Thomson effect or Seebeck effect, or we can say thermoelectric conversion effect. So it is nothing but semiconductors. Semiconductors are widely used for this kind of purpose. Thermoelectric power generation. So here I have mentioned here very low amount of current is induced inside the closed loop, and very low amount, very minimum amount of potential difference is induced. Because of this, it is not worthwhile, it's not worthful. So what we have to do, in order to get some remarkable amount of this EMF, induced EMF, so we have to go for some cascade system. That cascade system is nothing else in order to coupling each and individual units, either in terms of series mode or in terms of parallel mode. So parallel mode or series mode, we can cascade the system and can enhance the capacity or efficiency of each generators. So now next topic is the thermionic converter. Thermoelectric generators are devices that convert heat directly into electrical energy using phenomena called Seebeck effect, or these are also called as Seebeck generation working. So so thermionic conversion is what will happen when two different electrode is placed in a vacuum. So what happen, the electrode which is capable to liberate electrons is termed as cathode. So at very high temperature, the electrons cross the energy barriers and escape out from this place, and when they escape out that place, that surface is got positively charged, therefore a positive induction is there. Because of this induction, charge induction, a potential difference is maintained at two different two different electrode. Because of this potential difference at two different electrode, and induce EMF. Because of this induced EMF at two different electrode, electrical energy, or we can say electrical current, start to flow in external circuit that can be utilized for our purpose for variety of means, we can say. So in order to elaborate this phenomena in detail, to take help of this diagram. Here we can see here the vacuum tube is there, a cathode is there, a anode is there, and cathode is a electrode which is able to liberate electrons at very high temperature. In order to break out the energy barrier, the temperature should be very high. For this, an external source of heat is being employed in order to energize this electron. So the electrons is emitted from this place, and this surface is get ionized, positively charged, because this temperature positively charged, other one here is negatively charged. Ultimately a potential difference between two electrodes is induced, and ultimately an electric current start to flow in external circuit. So this is termed as thermionic converter. To escape the electron, must somehow acquire enough energy to overcome this energy barrier. An ordinary temperature, almost none of the electrons can acquire enough energy to escape. So therefore high energy should be there for increasing this, for receiving this amount of energy. External source of heat should be maintained at this place. So, and the liberation of electrons from hot surface is called thermionic emission, and this is only the source of thermal energy conversion to electrical energy conversion. So numerically we can say the density of current is equal to a t square exponentially minus 5